for welcoming us here. I'm going to cover a few topics very, very briefly. The slides will be available to you, so what I won't cover in detail here you can see. And one of the reasons that we focus on standards is, and why we're very happy to be participating with the IO500, is because the change of what AI is bringing to what had traditionally been HPC type of workloads. This is bringing HPC class requirements into the enterprise. We know that, and this is very simplified, traditional HPC MISIM, it's somewhat linear, it's somewhat focused. Of course, this is highly simplified. But AI creates a different challenge where you have to bridge across multiple sources of data, multiple locations of data, multiple locations of compute. And so the problem is that if it's in a proprietary format, or if the client's proprietary, that creates huge friction, especially for AI adoption in the enterprise. And so what Hammerspace has been doing since really in the late teens, 2018, is really focusing on how to bring HPC class performance into an open standard parallel file system. And we've done this through the contributions to the community for pNFS 4.2 with flex files. So this is taking what was the initial implementations of pNFS, which had a lot of the same problems that NFS had, and eliminating that, hardening it, eliminating the get out of traffic, and adding telemetry, nConnect, other features, so that you can bring that kind of performance. And the result is, at supercomputing last year, NFS, specifically pNFS, in the production performance 10 node with Samsung, a production environment using standard Linux, standard kernel, with nothing altered out of the standard kernel, and we broke the top 10. I'm not aware that NFS has ever been anywhere close to the top 10. As we all know, NFS means not for speed, at least it did until now. So what have we done? So since 2018, we've introduced a whole series of features. The Linux client kernel maintainers, co-maintainers are both on our staff, plus another maintainer and several key contributors. Our CTO is the kernel client maintainer. But these performance enhancements are really driving towards trying to achieve parity, not necessarily as a replacement to Lustre or other file systems, but as a way to bring into every data center on the planet that has Linux, which means every data center on the planet, a high-performance parallel file system. You can see these, again, but the main contributions are focused on bandwidth, of course, metadata scaling, and AI and GPU type of workflows. The Holy Grail is on the right. And what's coming and what's going through IETF right now is the N-to-1. And I'll talk about that in a second. So these metadata enhancements, if you kind of look through this, each of these has a primary impact on whether you're scaling, going beyond bottlenecks, increasing application workflows, but again, with a standard client. So because it's standardized on the back end as well as on the front, meaning no client software required on the front end, standard NFSv3 target on the back end, it means this can bridge any storage with any hardware. And that's really what you need to do. What we've seen though, and where pNFS performs today and where the future really is, and this maps to the results that we had from IO500 last November. So, strong in a lot of the areas, hard right, and some of the other areas, especially when it relates to the types of workflows that you might see in an N-to-1 traditional mod sim environment, that's where there's work coming, and that's really what's the next phase of this. So, can pNFS match traditional HPC file systems? I would say in some workloads, yes. Many workflows, particularly in an AI type of a context, absolutely yes. Many to one, not yet. And that's where the N-to-1 capabilities and what we're also introducing is a client-side erasure coding. These are going through IETF right now, and there's a lot of discussion. Well, we have it working, but we will never release it into a customer environment until it's really been adopted by the standards body. And so these are very important because, especially as you go into the enterprise, whereas in an HPC environment, a research environment, a lab environment, being able to do very specialized file systems with custom clients, custom hardware, that works. But trying to introduce HPC class performance into an enterprise environment where there's no expertise in this, if it's not based on standards, you're going to run into roadblocks, and that's what we see. I won't go into a lot of the other details here, but one example is being able to, and with the local I/O capability that was added to Linux in 6.12, it means that it's just adding intelligence to the client. Rather than expecting the data to be on external storage, we've added intelligence so that for local NVMe that's on a GPU server, for example, the client is smart enough to know that that the data is local and it can become a shared tier storage. So this is why Hammerspace is the way it is. It has to be standardized on the front end, so you're coming into any data on any storage from anywhere using any protocol without having to bridge authentication, without having to translate between object or file format, even being able to expose this with an MCP server endpoint so that you can see all of your data on a unified data plane. And then be able to access any storage of any performance level and then automate the orchestration of that data behind the scenes. So open standards matter. Standard client, standard server, standard protocol. We've seen this at least in the initial production last supercomputing with a top 20 IO 500 production list. But then this is not ending now. There's ongoing Linux kernel innovation that will be applicable in both AI and in HPC workloads. And that's my time.
Okay.